In the first chapter, we have learned about the chemical reaction, breaking of bone and formation of new bones. The representation of a chemical reaction, we call it as a chemical equation. In the first activity, magnesium ribbon burns in air to give us magnesium oxide. If you are writing it in words, this is called a word equation. And all what is present in the left hand side of the equation, we call it as the reactants. And the one which is there in the right hand side are the products. Now, instead of writing it in words, if you write it in chemical name, we call it as chemical equation. But when we are writing a chemical equation, see here left hand side, oxygen is 2, but right hand side it is only 1. So always we need to balance the chemical reaction. Why it should be balanced? In order to satisfy the law of conservation of mass. Okay, that means the total mass of the products should be equal to the total mass of the reactants. So there are certain steps to balance the chemical reaction. Okay, step number 1 is we need to put all of them in boxes. Okay, why we are putting it in box means you cannot make any change inside the box. You can write the number to the left of the box, but not inside the box. That means if you are putting Fe, you cannot make this to 3. Instead, you need to put the number outside the box. So that is the first step. You need to put the box for all the components. Okay. And then we will write LHS and RHS. Okay. Of all the elements which are involved in the chemical reaction. That means Fe is there, hydrogen is there, oxygen is there. So in LHS and RHS, we will write in this LHS 1, RHS 3. Hydrogen, LHS 2, RHS 2. Oxygen, LHS 1, but RHS 4. So we will identify the number of elements on LHS and RHS. And we will check which is most unbalanced. This is completely balanced, but the most unbalanced is oxygen. So we will try to balance oxygen first. How can you make this oxygen 4 in the left side? You put a 4 here. Okay. So automatically the hydrogen valency number goes. So it is 8. So you need to put a 4 here also. Now only iron is left. So you put a 3 here. So this is how we will put them in box, then identify the elements on LHS and RHS, and then we will balance the most unbalanced first. And this is our final form. 3Fe plus 4H2O, giving Fe3O4 plus 4H2. The last step is we need to write the physical state of the components. Like iron is solid, water is in the gaseous form. That means it is steam. Fe3O4 is solid and H2 is gas. So we need to balance it. Then we need to put the state. This is very mandatory that everywhere in chemistry, you're writing an equation. It should be a balanced equation. Now we will come to the types of chemical reactions. The first type of chemical reaction is called combination reaction. Combination reaction means 2 reactant molecules combine to give a single product. But always energy will be released during the combination reaction. So combination reaction is also called as exothermic reaction. And see the palm which is shown here, it is to show that some temperature difference is happening or heat is evolved. So the example which is given for combination is calcium oxide reacting with water. It will give us calcium hydroxide with the release of heat, and that is the activity and the diagram shown here. Okay. My children should be clear with 3 types of line. The first line, we call it as quick line. Quick line. Quick is the formula, that is CaO. What is it? Quick line is calcium oxide. Calcium oxide is quicklime. When you add water to calcium oxide, then you will get the second form of lime. We call it as slaked lime. So what is slaked lime? Adding water to calcium hydroxide. Calcium oxide. So what we will get is CaOH twice. Okay. Anything in water, we call it as aqueous. Okay. So slaked lime is calcium hydroxide. Calcium hydroxide. Now, to calcium hydroxide, if you are adding carbon dioxide, if you add carbon dioxide, it will become calcium carbonate. And this is called limestone, or another name is marble. So the chemical name is calcium carbonate. So there are three limes which are coming in grade 10, quicklime, slaked lime, and calcium carbonate or limestone. Now, during whitewashing, we are actually using calcium oxide. We mix it in water. Then you will see that the reaction mixture will have a temperature hike. Okay, it will become warm. This you will apply to the walls, and in 2 or 3 days, what will happen is calcium hydroxide slowly react with the carbon dioxide which is present in the air. And then the walls will become white in color, because calcium oxide is white, calcium hydroxide is colorless, but calcium carbonate is white. So you will get that finishing touch after whitewashing. Some other examples of combination reaction is carbon reacting with oxygen to give carbon dioxide. This is burning of the coal. Then formation of water. Formation of water is a combination reaction. The reverse of this is there. You can split the water. That is decomposition. Now, burning of natural gas, combination. Now, there is a respiration process in our life processes chapter where energy is released in the cells. Since energy is released during a respiration process, respiration is also considered as a combination reaction or exothermic reaction. Now, decomposition of vegetable matter. Actually, the name is decomposition, but actually, as energy is released, it is also considered as a combination reaction. I mean, precisely telling, it is an exothermic reaction. Now, the reverse of combination reaction. That is a textbook question also. Why decomposition reaction is called as opposite of combination reaction? Because in a decomposition reaction, AB, one single product will split into A and B, two products. But for this reaction to occur, it has to absorb energy. That is why all decomposition reactions are called as endothermic reaction. This is called as endothermic because energy is taken in. Okay. Energy can be taken in the form of heat. If so, it is called a thermal decomposition. Energy can be taken in the form of current. Then such type of a decomposition, we call it as electric decomposition. And third one is light. If it is light, such a decomposition reaction, we call it as photodecomposition. Whatever it is, any decomposition reaction to take place, there should be energy intake. See the diagram? The girl is keeping the test tube. She has put ferrous sulfate crystal. Okay. Remember, children, ferrous sulfate crystal means FeSO4 7H2O, whose color is green. When you heat this, first this water will go. Then it will become ferrous sulfate, which is colorless, or we can say that it's white in color. Again, when you heat, anything when it is heated, okay, the corresponding oxide will be formed. If it is ferrous sulfate, ferric oxide. And since it is sulfate group, sulfur dioxide and sulfur trioxide are released. And the color should be clear to you. FeSO4, 7H2O is green. Then it will turn white. Then it will turn reddish brown. Reddish brown. This is the color change what is happening. And always after a decomposition, it will be releasing the oxide form. Now, don't forget about this ferric and ferrous. Iron has 2 valency. 2 plus is also there, 3 plus is also there. If it is 3 plus, it is called a ferric. Okay. So Fe 3 plus react with oxygen 2 minus will give us Fe2O3. So what is this oxide? Ferric oxide. Whereas if it is Fe2 plus reacting with O2 minus, it will give FeO. This is ferrous oxide. Ferrous oxide. So the first thermal decomposition is ferrous sulfate. Second, 3 decomposition is there with the heat. If it is calcium carbonate, it's very clear that what is the oxide form? Calcium oxide. And which is the gas released? Since there is carbonate group, it will be carbon dioxide. If it is sulfur dioxide, sulfate, sulfur dioxide. Carbonate, carbon dioxide. Now, one more decomposition with the heat is there, that is lead nitrate. Lead nitrate, when it is heated, PbO. So, lead nitrate will give us lead oxide. Lead oxide, okay? And corresponding oxide, since there is nitrate group, it will release nitrogen dioxide. So, 3 thermal decompositions are there, FeSO4, CaCO3, and lead nitrate. Now, all the colors should be clear to all of you. Now comes the second decomposition is with respect to current. Always remember, children, anode, okay? Anode and cathode. These are the 2 electrodes. Anode means Ana. Ana is elephant. This is positive omen, okay? And cathode, cat running is negative omen, okay? So one will be cathode, one will be anode. So cathode is negative and anode is positive. So what is getting split is water. When water split, it will give us H2 plus O2. So you know that H2 is H plus. So H plus will be released near cathode. See? And O2 minus, negative ion will come to anode. So here you will get oxygen and here you will get hydrogen. So this is the decomposition reaction with the help of current. Okay. So 2-3 questions are asked from this. One is, for this reaction, we actually put some acid in it. Acid will help in easy decomposition. So many schools are asking why we are adding acid. Acid helps in the easy decomposition of water into hydrogen and oxygen. Now we need to balance this. When we balance, actually 2H2 is giving 2H2 plus O2. So as it is balanced, you will see that 2 molecules of hydrogen will be forming only one molecule of oxygen. So what is the volume ratio of hydrogen to oxygen? It is 2:1. Volume ratio is 2:1. But what is the mass ratio? Mass ratio. Mass ratio means we need to consider the mass. So 2H2 means 4 times H will come. And O2 means 2 into 16 will come. Oxygen mass is 16. O2 means 2. 2 into 2, 4 hydrogen. And mass of hydrogen is 1. So it will be 4:32. That is 2:16. That is 1:8. So volume ratio is 2:1, but mass ratio is 1:8. So please check whether they are asking hydrogen to oxygen or oxygen to hydrogen. If it is oxygen to hydrogen, 1:2 and 8:1. So that's the case of electric decomposition of water. So why we are adding a small quantity of acid to it? It is for easy decomposition. Now, photo decomposition is very easy. Only one metal is taken there, that is silver. Either silver chloride or silver bromide. Okay. When decomposition occur, this is with the help of sunlight. So in sunlight means photo decomposition occur. It will split into Ag plus Cl2 because chlorine cannot exist by Cl. Same is the case with Ag plus Br2. So when you balance, it is 2Ag, 2Ag. So basically, AgCl and AgBr are all white in color. Okay. So white color silver chloride will turn into gray. What is gray? Silver color. And this is mostly these two reactions are used in black and white photography. So we have completed till balancing of chemical equations and two types of reaction. Chemical reactions are combination reaction, A plus B giving AB, which release energy, that is exothermic, and AB splitting into A and B is endothermic. That means it takes in energy in the form of heat, light, and current.